Welcome to the first video in a series that aims to introduce students to basic MATLAB programming. So the version of MATLAB that I'm using here is 2019A, and when you open the MATLAB for the first time, this is the general layout that you see for the software. So on top you see you have a list of menus. We have home, we have plots, we have additional apps that either come with the MATLAB itself or you can add them as an add-on or extra toolboxes. Then we have this field that shows the current folder that all our file will be saved in. So this is not the default folder. I created a folder myself and then put the address here. On the left we have the current folder. This basically lists all the files that are inside or off in the folder. In the middle we have the command window. Basically this can act as an interface for you to put your command, define your variables, or run any function that you have. And on the right we have the workspace, which lists all the variables that are defined for being used inside the MATLAB. So as you can see here, for now it's empty. So in the command window we have this prompt which is blinking and shows that it's ready to accept your input. So one of the first things that I suggest all the students to do whenever they open MATLAB for the first time is to type demo. So this creates another window and it contains a lot of examples in the MATLAB software that you can use. As you can see here, we have examples as simple as basic matrix operations or more advanced ones like FFT, fast Fourier transform, how to create 2D plots, how to work with different toolboxes. For example, we have Aerospace toolbox and the example associated with that, or something that is probably more interesting to some of you, the deep learning toolbox that you can use for all AI and machine learning applications that you have in mind. It can be done on time series data or for classification of image data. Another thing that is very useful is the help section of MATLAB. If you type help, you see this message is being shown, and if you know the name of the function that you are looking for, by typing it after the help, you see the information associated with that file. So for example, if I type help sign, this gives me the information that is associated with the sign function and shows its basic use. There are also some similar functions that is being suggested here. So this one is the assign function, or sign D, which is basically the sign function with the input arguments in degrees rather than in radian, which is the default. If you want to open the help browser, you can just type help browser here and it will open the help browser of MATLAB. You can search through the documentation for different functions. So when you do that, when you start typing, it shows the list of functions that start with that phrase or contain that phrase. So for example, if I just type SIN, the first thing that shows is the help for the sign function. And you see here that you have access to more information, you have examples of uh, any function that you want to use, the list of input, outputs, if there is any mathematical foundation behind that function, it's also mentioned as well. So one of the ways that you can use MATLAB is just the same way as you use a calculator. So this is the thing that I want to focus uh, mainly in this part of the video. So just as you do with a simple calculator, you can just type any number that you want. You can do any operation, and then by pressing the enter key, you get the result. So as you can see here, I have put some numbers, added them together, multiplication, division, and as you can see, after pressing the enter, I got the answer. One thing that you notice here is that we have this variable now in the workspace named ANS, which is short for answer, that contains the result of that operation that we just performed. There are other things that you may notice in the workspace too, is that other than the name and the value, the number of bytes that is being used to store this value, as well as the class or the type of the number, also minimum and maximum of that number are also mentioned here. You can add additional attribute here, which is not useful, at least for the basic examples that we have here, but whenever you're working with multi element or multi-dimensional matrices and vectors, some of them may be useful. So as you can see here, the default variable that MATLAB is using is ANS. So if I just type another set of numbers, you see that after computing the answer, it is saved in the same variable. And you can see that in the workspace too. So it's a good practice that you define your own variables, and the way to do it is very simple. You just put a name for your variable, then equal sign, and then you can put your operation. So if we do that, now we have a variable a with this value, and in the list of variables in the workspace we have variable a as well. As you can see, the value is stored, the number of bytes is the same as before, and the class of the number or the variable is double. So double is the default type or class of any variable that you define. One thing that you should notice is that the name of the variable always comes to the left of the equal sign, and the operation comes to the right. So let's just try to see what happens if we do it the other way. So if we just, for example, type 6 equals b, we get an error that says this is an incorrect use of the equal sign. One other thing that you should notice is that this equal sign is a bit different than how you use equal sign when you're working with pen and paper. This is more of an assignment rather than equal sign. If you want to use a equal sign as a true equal sign, you have to use two equal signs right after another, and this is something that we will check on later. So one thing that usually happens in programming is that we don't want to see the result of all of the operations all at once. So one thing that we can do to prevent that is by using semicolon. So let's just say we want to define variable b and we want to assign it a value of 678. So if I just press enter, it shows the value of b. But what if I define another variable called c and assign it a value, and then I put semicolon at the end? So after doing that, you see the value of c is not shown anymore, but the variable c is stored in the workspace. So at the end of any line of code, if you don't want to see the result of that operation or that statement, you can use semicolon to basically suppress the showing of the output. So let's just say now you have defined a variable and you put the value by mistake. One of the things that you can do is that you can just retype the whole expression, but there is a shortcut too. So you can use the arrow keys to go to the previous statement that you had. So for example, if I go back to this statement and I change this number into 0, now the value of variable a has changed. So now a with a new value is stored in the workspace. So now that we saw how we can define simple variables, it's good to talk about how we can put meaningful names for our variables. So one thing that you should always have in mind is that the name of variables always start with a letter. So let's say if I try to create a variable named 1ab and assign a value of 7 to it, you see I get an error because the name started with a number, and the MATLAB even suggests an alternative to correct the error. The other thing that you should always consider is that there is a hard limit on the number of characters that you can use for creating a variable. So to get that number, you can just type name length max, and after doing that, you see the answer to this function is 63. So that means that if you define a variable and its name is longer than 63 characters, whatever character after the 63rd character will be eliminated. So if you have, let's say, two variables which for them the first 63 variables are exactly the same, then those two variables won't be two variables anymore. They are gonna be one variable. So this is something that you have to keep in mind. Another thing when you're naming variables in MATLAB is that MATLAB is case sensitive. So if I define variable a and assign a value of 7 to it, and also define a variable a and assign a value of 5, you can see in the workspace I have both of these variables. So it is very important that you keep that in mind, that MATLAB is case sensitive. So what happens if we want to define a variable with a combined name? So let's say we want to define a variable called volume of a sphere. So one of the ways that you can do that, you can just use underscore to define the variable. So let's say we have volume of a sphere that is 65. So this, as you can see, is a valid name for a variable. Another way that is usually very common is by defining our variable using a combined name. Equals 65 by defining the variable name using a combined name. So this is usually more common, especially since some of the programs that interact with MATLAB cannot handle having underscore in the variable name. So usually it's suggested to. So as I said before, the name of the variables and their properties are placed in the workspace. So there are some functions that give you the capability to list the name of the variable and get any information that you want from them. So one of them is who. So if you do that, it gives you the list of all the variables that you have already in the workspace. There is another function whose, which in addition to the name of the variable, it gives you an idea about the size, the number of bytes, the class, and other attributes for any variable that you have. So let's say you want to delete a variable. So one way to do it is by clicking on it and then right click, and then you can press delete, and then that variable is deleted. You can do it using some functions too. So you can just use function clear and then the name of the variable, and by doing that, after pressing enter, that variable name is deleted. You can delete multiple variables using this technique as well. So let's say we have clear AB, ANS. If we do that, those two variables are going to be deleted. One other way to do it is that if you just type clear without any variable name, or clear all, if you do that, all the variables inside the workspace will be deleted. Using the format function, you can define the format of the variable that you have. So there are there are 4 different formats that you can have: short, long, loose, and compact. So the 2 main ones are short and long. So let's just go for an example. Let's just say we have this function sine of 1.4. So if I do this, as you can see, there are 4 decimal places that are shown for variable a. If I change the format to long and then try to show the variable a, as you can see, more number of decimal points can be represented using this number. So to go back to the default, you can just type format short, and this basically goes back to the previous format. One other thing that you see here is that, and there are some rounding that happens between the two as well. So the numbers after the decimal point here are 97089, and this is rounded to only 4 decimal numbers after the decimal point. So there are some basic operators that you can use with MATLAB. We have the plus, minus, multiplication, division, left division, and so on and so forth. So some of these operators need only one operand. So for example, we have a variable a with the value 1.9709. So let's see if I want to create variable b as negative a. This negative only needs one operand. But let's say if I want to create variable c as the as the subtraction of b minus a. So what you see is that this operator can be used with more than one values as well. So one thing that you should always keep in mind is that the order of the operators are not all exactly the same. So the priority is different for these different operators. To see one example, let's just try to compute variable d, which is equal to 2 plus 4 multiplied by 6 minus 5, and see what is the value for this. So in this equation, the multiplication has the highest priority between all these three operators. So first 4 multiplied by 6 is computed, then the addition, and then the subtraction. But let's see if we have variable k, which is defined as 2 plus 4 in parentheses multiplied by 6 and then minus 5 and the end of parentheses. So if we do this, the value for k is going to be 31, and this is something that you should always keep in mind, that you cannot expect the program to know what you want to do. So if you want to sum 2 and 4 first and then multiply the result by 6, you have to specify it yourself. So overall, the operators parentheses have the highest priority, then the power operator, then the negative operator, then is multiplication and division, and finally addition and subtraction. There are other operators that I'm not going to talk about now. You will see how they can be used later on. There are many built-in and internal functions that are defined in MATLAB. They're defined for different applications. So these functions come under different subjects and categories. So one of the useful ones is called elfun, which is basically the list of all the elementary functions that you can use with MATLAB. So to get that list, I can just type elfun, and this gives me a list of elementary functions that can be used. For example, we have trigonometric functions, we have the exponential functions, we have complex functions, we have rounding and remainder functions. Each one of them, if you click on the link, you are given the basic help explanation for that specific function. In addition to the internal function, there are some constants that are defined within the MATLAB. So one of them is the value for pi, and since default format right now in the MATLAB is short, it only shows the variable onto 4 decimal points. If I change the format to long and I type pi again, now you see that you have the value for pi with much higher accuracy. The other constant that is internally defined in MATLAB is I, which is basically the complex number square root of -1. There is j, which basically has the same definition. You have inf, which basically is the infinite value, and then you have nan, or nan, or not a number, which is usually used when some equations produce a value that is not necessarily a number. For example, if you have 0 divided by 0 or infinity divided by infinity, the value is not a number. So if I want to show you an example, for example, sine of 0 divided by 0, if I assign this to a variable called z. As you can see, the value of z will be nan, or not a number. As said before, the default class or variable type is the double class, but there are other types of variable that you can have. So one of them is single. So let's just say we define variable a as let's just clear all the variables in the workspace first. Let's just define variable a to be 5, and as you can see, the default class is double. Now let's say we want to define a variable b as single of 5. Now in the list of variables in the workspace, we have variable a and we have variable b. The value of both of these variables is exactly the same, but the difference is that since variable a is a double and variable b is a single type variable, the number of bytes that are used to store these two variables is different. So with double we are using 8 bytes, but with single variable we are using 4 bytes. But these two are not the only ones. We can have the variables of class integer of different size. For example, we can have integers of 8 bits, integers of 16 bits, integers of 32 bits, and so on and so forth. Also, we can have variables of only positive integer numbers, for example. So let's just see what one example. So depending on the number of bits that is used to store a variable, there is a range of value that can be stored in that variable. So to get that range, let's just have this function. It's a predefined internal function in MATLAB, and you can pass to it the type that you want to check. So for example, if I check the integer minimum that can be stored in an integer 8-bit integer number, the answer is -128. I can do the same to see its maximum too. So integer maximum, the number, an 8-bit integer number, is going to be 127. But what about unsigned numbers? So there is a type for that too. So for example, we have the unsigned 8-bit integer. So it's shown with UINT8, and the minimum value that can be shown using an unsigned 8-bit integer is 0. Let's see what is the maximum value that can be shown using an unsigned 8-bit integer. So it's 255. So this is something that you should always keep in mind, and that is the type of the variable that you're working with. If you're working with variables of size 8-bit, for example, you cannot store values that is not in the range of possible values. So let's see if I define a to be unsigned integer of 8-bit and I put the value to be 455. If I do that, even though I specified the value to be 455, the value that actually is stored in A is 255. You can see it here too. And the reason for that is that the maximum number that can be stored in an unsigned 8-bit integer is 255. So usually this is not going to be problematic for general purpose programs that we write, but there are some cases that you can use these different types to achieve better performance. So we are not going to talk about them here. In some applications it is useful to create random numbers, and In fact, there are some functions within the MATLAB that give you this possibility. So let's just see some examples. So let's just try to define a variable a with a random number. So the simplest function to do that is rand. So if I do this, it gives me a random variable which is drawn from a uniform distribution. What if you want to create a random number that is integer instead of a floating point? So one of the functions that you can use is rand_i. So for rand_i, you usually specify maximum number. So let's just, for example, put rand_i of 87. So this is the maximum possible number that will be created. So if I just press this, it shows an integer that is smaller than 87. If I run this one more time, it gives me a different random number. If I do it one more time, it gives me a different random number. But the whole point is that all of these numbers will be smaller than 87, and also all of them are going to be integers. There's another function that we can use which is called rand_n. For rand function, it draws the number from a uniform distribution. With rand_n, it uses a normal distribution of numbers. There is another function which is called rand_perm, and it's usually used when you want to create some random integers that have no repeated values, which might be useful in some of the applications. One thing that you should notice is that these random numbers are not truly random, rather they are semi-random, and there are different random number generators within MATLAB that you can use, which for now I'm not going to talk about them. It is not always the case that you want to define variables that their values are numbers. What if you want to define a variable that its value is a character? So to do that, you can create those variables and put their values in a single quote. For example, let's just say if you want to define a variable with the name grade, and we want its value to be character A, we do it in a single quote. And as you can see, in the list of variables in the workspace, we have grade, the value is A. It uses 2 bytes to store this value, and the class or the type of the variable is a character. You can show the equivalent ASCII code for this variable as well. So if I just type double of grade, basically convert the class of the grade to double. If I press that, you see that the value is 65, and that's because the the ASCII code for capital A is 65. So the values that we defined so far, they are called scalars. And scalars are basically 1 by 1 matrices. So I didn't talk about this before, but if I add this extra attribute to the workspace, you can see that the size of all of these variables that we define is 1 by 1. But just in case if you don't know, MATLAB is short for Matrix Laboratory. So its a trend is when you are working with vectors, arrays, and matrices. So let's see how you can create both row and column matrices. So one of the simplest way doing that is by defining all the elements of, for example, a row matrix one by one. So to do that, let's just create a variable vector, put the equal sign. To define all the values of this vector, we just put them inside a square bracket. So let's say the first element is 3, we separate it by a comma, then 4, then 6, and if I press enter, you see that the variable vector has 3 values, 3, 4, and 6. If I go to the list of the variables in the workspace, now you can see the size is 1 by 3, so it's 1 row and 3 columns. Instead of comma, you can just put space, and it basically gives you the same thing. So vector 2 is exactly the same as vector. What if you want to create a column vector? So to do that, you just put the values, and between them, between each row, you just put semicolon. So vector 3 is now a column vector, and its size is 3 by 1. But this is not always useful, especially if you want to create arrays or vectors of larger size. Specifying them element by element is not usually very useful. So one of the features of MATLAB is that it gives you the ability to basically define some rule in order to create a sequence of numbers. So one of the operators that give you the access to do that is the colon operator. So here we have the vector called vec equals 1 colon 5. If I press enter, you see that it creates a variable not named vec with the values being 1, 2, 3, 4, and 5. Since we didn't specify the increment, it assumes its default value, which is 1. If you want to specify the increment, you can just add an extra argument for the colon operator. So by doing that, now our vector is 1, 3, and 5. What happens if instead of 5 we had 6? You see that 6 is not going to be inside it anymore. Why? Because between 1 and 6 there can be only 3 and 5 which with increments of 2. There are some functions with more capabilities other than the colon operator that you can use. One of them is called Linespace. So the way that you can use Linespace is like this. So let's just say we want to create vector 2. We define, we use the function Linespace. We put the starting point, the ending point, and we just specify the number of elements that we want this vector to have. So if I just say 15 and press enter, you can see that it creates a vector of size 1 multiplied by 15. Each of the elements are double, and it basically divided the space between 3 and 10 into 15 sections. So you see they started with 3 and then 3.5, 4, 4.5. So let's just go back to the short format so we can see it much easier. So this is the values that vector 2 contains now. Let's just try it with something different. So you see that it basically creates all the decimal points between 3 and 10, including 3 and 10. So that's a good way if you want to divide a section of, for example, your plot into uh, divisions of exactly the same type, the same size. So let's just say you want to create a matrix now. So to do that, let's just call this mat1. So you basically do it row by row. So for each row, if you remember from before, we either use comma or space to show the element of uh, the row, and then to go to the next row we just put semicolon. So if we do that, now we created a matrix that has 2 rows and 3 columns. So now you might ask, okay, so how can we access a certain element of a matrix? And the answer to that is very simple. So to get that, you just provide the indices of that specific element. For example, here we have matrix 1. Let's say we want to show the element in its second row and second column. So to do that, we just say mat1, 2, and 2. And if we do that, you see that this element is going to be shown at the output. I can try it with another matrix. So let's just this time try to use the one of the random functions that we used before, random generator function that we used before. So rand5, let's say we want to create a 5 by 5 matrix of random variables. So as you can see, this is the random or pseudo-random matrix that is generated using the rand function. Let's just say we want to get access to the variable that is in the 4th row and the 2nd column. And as you can see, this is the variable that we had access to. So one of the use cases for accessing certain elements of a matrix or a vector is that if you want to change its value. So let's just say we want to change the 4th row 2nd column value of the matrix 2 that we just defined. We just simply say mat2, 4, and 2, and we just want to put it as 10. So if I type mat2 and press enter to show it, as you can see, now the value for that specified element is going to be. So what if you want to access all the elements within a specific row or column of a matrix? So the answer to that is you can use the colon operator that we used before. So for example, let's say we want to get access to all the elements within the 3rd row. So we just put 3 as the number of the row that we want to see, and for the 2nd argument we just put colon. And if we do that, you see that all the 5 elements of the 3rd row are accessed. You can do the same for the column too. So let's say if you want to access all the elements of the 2nd column, we use colon for the row argument, and for the column we use number 2. And if we do that, the result is a column vector that has all the values of the 2nd column of the matrix. Just like what you did with a colon operator before, you can specify the number of increments too. So for example, in the previous example, instead of showing all, if I just say 1 with increments of 2 all the way to 5, what I get are the 3 elements from the matrix with the increment of 2. So this is the first one, the next one would be this, and the last one would be this. So this is when you know the number of elements in a matrix. What if you don't know the size? So instead of the last value in the colon, you can put the keyword n, and it will give you the last value. So instead of mat2, as we did before, instead of 5, if I put end, it basically gives me the exact same result. So now this brings up another question. How can we get the size of an unknown matrix? Of course, we can always go in the workspace and check the size, but sometimes in a program we don't want to go to the workspace and check the size. We want to get it from the matrix itself. So there is a function that gives us this capability. So the function is called size, and if I pass to it matrix2 as the argument, the output is going to be a row vector with 5 as the number of rows and 5 as the number of columns. You can do this for any vector too. For example, the vector that we defined before is a row vector with the size 1/3. So if I pass that into the size function, I get the value of 1 and 3. Basically, it shows the number of rows, which is 1, and the number of columns, which is 3. There is another function that can give us this capability, and this is specifically useful for the vectors. So it's the length function. So if I pass the previous vector into this function, you see it gives me that the length is 3. So that means that if you have a function that is a column function but with 3 rows and 1 column, the answer to this would be again 3. What happens if we give this function a matrix? It says the size is 5, the length is 5, and that's basically the size of the longest dimension. So since here the size of the matrix was 5/5, the length is also 5. So with matrices, there are some functions that you can use to perform some specific operations. So one of the very basic ones is the transpose operation. Basically, it switches the rows with columns. So let's just say we define mat3 to be mat2 with semicolon. And if I press this, and let's just put mat2 again so we can see what's happening here. So as you can see, mat3, the first row is basically the first column of mat2. The second row is the second column. The third row is the third column. There are other functions that can be used with matrices too. One of them is flip UD or flip up down. So let's just define mat4 to be flip UD of mat2. If I execute this function, you see that this matrix is flipped upside down. So for example, element with value of 10, which was in the fourth row and second column, now it's in the second row and second column. There is another function is flip LR or flip left to right. There is another function which is called rotate 90. So let's just try to use this one too. mat2, and it basically rotates the matrix by 90 degrees counterclockwise. So the element here in the fifth row and first column is basically the element in the first row and the second column, and the first column. The element in the fourth row and the first column is basically the element in the first row and second column. Basically, as you can see, if you rotate mat2 90 degrees counterclockwise, you get to the result mat5 that we got now. So another form of manipulation that we can have with matrices is when we want to basically augment them to create larger matrices. So the way to do it is similar to the way that we defined matrices in the first place. So let's just say we want to create matrix 6, which is an augmented version of matrix 2 and matrix 3. So to do that, we use a square bracket. We just put mat2 and then mat3. So the way that this thing works is that since we said that we have mat2 with a space and after that mat3, that consider each one of these to be one element of a row. So in the first 5 columns is mat2 and the last 5 columns are going to be mat3. What if you wanted to stack them on top of each other? So that's also very simple. So you again use square brackets, but this time between mat2 and mat3 we use semicolon, and that tells MATLAB that you want the matrices to be stacked on top of another. Since MATLAB is designed to work with arrays, vectors, and matrices, that means that a lot of the time you can pass matrices as arguments to your functions. So we saw that before, that we can pass a single argument to the sine function. For example, if I just say sine function of 0.5 radians, it gives me the value. What if I want to pass the whole matrix and see what happens now? So let's just say the sine of mat7. As you can see, the output is going to be a 10 by 5 matrix because the input matrix was 10 by 5. And for each one of these values, the sine function is applied individually. So the sine function is working element wise on all of the values of the matrix. The size or the values of elements of a matrix are not always defined or always known beforehand. So one of the capabilities of MATLAB is that you can define a vector or matrix of size 0. So I can try this here. So if I say mat8 equals square bracket without any element inside of it, we have mat8 with no values inside. If I go to the list of variables in the workspace, I can see that the size of this is 0 by 0. You can manipulate this matrix just like you did before. So let's say if I want to create a matrix 9 which contains matrix 8 and a list of numbers from 1 to 4, basically a series of numbers. Since matrix 8 was 0 of size 0, when you put these together, the value that is the matrix that is created is going to be only values from 1 to 4 with increments of 1. There are some other functions that can give you matrices of predefined values. One of them is the zeros function. So we can have zeros of 3 and 4, for example. This gives us a matrix of size 3 by 4 with all the values to be 0. Another one is the ones value. So we have, let's say, mat11 to be ones of 5 by 4, 5 by 4, and it gives us the matrix of 5 rows and 4 columns with all values being 1. Another example is the I matrix, basically the identity matrix. So for this one, if the matrix is a square matrix, you only need to specify one variable, and the output is going to be size that variable by that variable. So for example, if I say I of 6, it gives me a 6 by 6 matrix with all the diagonal elements to be 1. You can basically provide only one variable to the ones and zeros function to. In that case, the output is going to be a square matrix. Another good example of functions that give us predefined matrices is the magic function. So let's just say we have mat3 to be magic magic of 4. It gives us a magic matrix of size 4 by 4, and the property of this magic matrix is that the sum of all the elements in each row and the sum of all the elements in each column and the sum of the diagonals is going to be exactly the same. So all the matrices that we saw so far were two-dimensional, so we only had a certain number of rows and a certain number of columns. What if you want to define a higher dimensional matrix? And the answer to that is very simple too. So any of the functions that we use so far, you can use them for creating higher dimensional matrices. So let's just create a random function of 3 by 4 by 5 as the size. So I can just say mat14 equals rand n of 3 by 4 by 5. If I do that, as you can see, mat14 is a matrix of size 3 by 4 by 5. The same way that you could access elements of two-dimensional matrices, you can get access to elements of three-dimensional matrices too. But the difference is that now you have to specify 3 indices. So if I want to see what is the value for 1, 2, and 4, sorry, 1, 3, and 4, the value that is created for this random matrix is negative 0.1924. You can use a column to basically show a list of variables, or for example here, since we have a three-dimensional matrix, let's say if you want to show all the variables, for example, that are having a certain row or column number. So let's just say if you want to have mat14 of 2, 3, and then column. So when we do that, you see that we get 5 different results. So one thing that you might notice is that the result of this operation is not a single vector anymore, because our matrix is three-dimensional. It shows it element by element. So this is the value in the second row and third column for the first, you can say, a slice of the matrix 14. This is for the second slice. This is for the third, all the way to fifth element. So in this part of the video series, we went over some of the basic functionalities of MATLAB. Hopefully in the following videos we will go into more details and talk in more depth about different parts of MATLAB and how we can use it more efficiently for our specific applications.